Not 6. So number 7 next, right? Number 7 next. That's what it's called universal set. In bracket U. Universal set in bracket U. A universal set is simply a set of all possible elements. Full stop. A universal set is simply a set of all possible elements. Full stop. Next up, let's look at complement of the set. Given a set A, comma, the complement of A is written as A prime. That's A by 1. Given a set A, the complement of A is written as A prime. That is A by 1. It gives the elements in the universal set that are not in A. It gives the elements in the universal set that are not in A. The elements in the universal set that are not in A. That's it. Example. Let's say I have a universal set as being equal to 1, 2, 3, 4, 5, 6, 7, 8. Alright. And I have A as being equal to, let me use set builder notation, X, such that X is an even number less than or equal to 6. Let's say I have B equal to, I want to use set builders. So B is equal to X, such that X is an odd number less than 7. Alright, so let's have asked to find the complement of A and the complement of B. So I'm asked to find it. What do I know? So look at it. My A complement, before I get, of course, this is how you see it in jam cases. Alright, before you get your complement, your first task is to what? Describe A. Alright, change it from set builders to what? The listing. So list it out. Let's say I want to list A. A will be equal to what? Please help me out. What will A be? Please, when it comes to listing A, please, will I add 6? Yes or no? Yes or no? Yes. Why? Because what there? And equal to. So my even number is what? 2, 4, I'll add 6 because it's what there? An even number. So it gives you what there? 2, 4, and 6. So this is my A. What will A prime now be? We said A prime is equal to all those elements in the universal set, but what there? Not in A. So which element do I have in my universal set, but I don't have in A? Look at this please. Check. What is here but not here? What do you have? Huh? 1 first. Next up. Next up. Next up. Is that all? Huh? 8. Abi? That's all. Alright. Let's get B. For B, they said B is what? Odd number, and B is what? Less than 7. Please, for less than 7, will I add 7 there? I won't add 7. So help me list out odd numbers less than 7 from here. What do you get? 1, 3 and what? I will not add 7, Abi, because there's no equal to something there. For this, I added 6. Why? Because I'm equal to. For this, I don't add 7. Why? There's no equal to. If I have this, please help me out. Give me B prime. What do I have? Huh? 2, 4, 6, 7, 8. Are we good, please? Are we good, please? Any confusion? What's confusing? Which of them here? This one? What's B? What's B? What's B here? What are odd numbers? Let's start the odd numbers. What are the odd numbers you know? Okay, so from here they say pick out odd numbers less than 7 from here. What are your odd numbers here? 1, 3, 5, 7. These are the odd numbers here. Now they say odd numbers, that's what here? Less than 7. For less than 7, will I include 7? No. So don't include 7. I only have 1, 3, 5. That's it. Let's see relative complement or difference of sets. Who was asking? I don't get what's A prime? What's really your this one? What's A prime? Universal set. What's a universal set? What's a universal set? This one here. Where's your A? So look at universal set. Look at A. Which element is here but not there? Huh? Let me listen. What I'm saying is simple English. You get it? That's it. Elements here but not here. It's clear. There's 1 here. 1 is not there. So put 1 there. There's 2 here. There's 2 here. Leave it out. There's 3 here. There's no 3 there. Put 3. There's 4 here. There's 4 there. Leave it out. There's 5 here. There's no 5 there. Leave it out. There's 6 here. There's 6 there. Leave it out. Okay. There's 7. No 7. Put it. There's 8. No 8. Put it there. That's it. Alright, let's do relative complement or difference of sets. Take that, please. Given two sets A and B, given two sets A and B, the difference between the sets is given by A minus B. The difference between the two sets is given by A minus B, or perhaps B minus A. You want to? The difference between the two sets is given by A minus B, or perhaps B minus A. A minus B gives the elements in A that are not in B. A minus B gives the elements in A that are not in B. While B minus A gives the elements in B that are not in A. While B minus A gives the elements in B that are what there? Not in A. That's it. That's it. Look at this case. Look at this case. If I have A as this and B as this, what's A minus B? A minus B are elements in A, not in B. So look what I have. Tell me the elements that are in A but not in B. What do I have? 3 and 5. That's 3, 5. That's it. These two are in A, not in B. This one is in B, so I'll leave it out. Now what will now be B minus A? Elements in B but not in A. What do you get there? 4 and 2. That's all. That's all. Any question? Look at this again. Let's say I have C being equal to 1, 4, 7, 3, and D is equal to 1, 2, 3. Alright, for these things, what's C minus D here? What's C minus D? Nothing, Abi? Yes, because all the elements in C and what are in D. How do you write nothing in set? What do you write it? That's 5 empty sets. Abi? Or what? Only. Hope you get it now. Alright. Let's look at the basic operations of set. Set basic operations. Set basic operations. Alright. Let's start with the first one called union of sets. So the first one called union of sets. Given two sets A and B, given two sets A and B, the union of the set is written as AUB. Not UBO, AUB. Huh? That's AUB. And observe, in my U, I didn't use a tail. I didn't use a tail. I didn't say, look at this, I didn't say AUB. I didn't put this tail. Look at that, look at it, looks like this. That's AUB. It gives the combination of all the elements. It gives the combination of all the elements in A and B without repetition. It gives the combination of all the elements in set A and B without repetition. In set A and B without repetition. For example, let's say A is equal to 1, 3, 4, 5 and B is equal to 2, 3, 5, 7. Look at this. What's A union B? A union B is equal to, I'm combining all the elements in A and B. If there is one that's repeated, I will not repeat it. That's how we said without repetition. So let's come here now. Combine all the elements. What do you have here? 1. What again here? 2. There is 3. There is 3. You don't write 3, 3. You don't repeat. It's no repetition. So what's next here? 3. Next up. 4. What next? 5. What next? 7. So this is A and B. I'm combining all the elements in A and B. I'm not repeating. Now look at this thing. Look at this. If you are asked to find N of A union B, what will be your answer? When we say N of this, what does N mean? Cardinality. So before now, to give you an example. What's cardinality? It's what there. All the elements was a set. So how many do I have here? 1, 2, 3, 4, 5, 6. 6. Did you get A union B? What's the issue? What's the issue? Which of them? This one or this one? This one here? This one here? What's A union B? What does it mean? In A and B. Where is A? Where is B? So combine all the elements there. What do you get? What's the first you have there? What's what you have there? Right? That's why I say you should go and read. This is how you learn actually, right? And as I'm teaching now, I'm not expecting that you know everything now. That's how you learn. Right? If I'm teaching, what I expect is just listen to what I'm saying and write it down. By the time you read it or you do what, you understand it. That's how you learn. Is that okay? Yes. It's an error to think that you come to class, so I'm teaching that you understand everything. No, that's not how you learn. Usually, what happens is that you get the information of how it was, write down it correctly. By the time you read it out and then look at the example, it will just come naturally. That's it. So just really understand. What's A union B? Simply combine the elements. That's it. Combine this and this without repetition. This is 5, 5. Don't say 5 over 5. No. Just 5, 7. That's it. Alright, number 2. Intersection of sets. The basic set operations. First one is union. For union, what am I doing? I'm combining all the elements without repetition. Let's look at intersection of sets. Given two sets A and B, given two sets A and B, their intersection is written as this: A intersection B. A intersection B. So this sign has, look at that, it's like a PlayStation keypad, right? Look at this. It has its left, it has its right, it has the up. What's on there? Down. What does this mean there? Subset. What does this mean there? Superset. Discussed before. What does this mean there? Union of sets. What does this mean there? Intersection of sets. It's like say four dimensional whatever. Alright, back to this. We said it's written as A intersection B. It gives only the elements that are in A and B. Full stop. It gives only the elements that are in A and B. It gives only the elements that are in A and B. Let's say I'm to take the same example to say let A be equal to 1, 3, 4, 5 and B be equal to 2, 3, 5, 7. What is A intersection B? Get the difference. When it comes to union, combine or do repetition. When it comes to intersection, what do? Collect what? You like them. The ones that was common to what? Both of them. Look at this thing. Which element is common to both A and B? 3 and 5. Becomes 3, 5. That's the intersection. Example please. Given T is equal to, it says even numbers from 1 to 12. That's T. We say N is equal to common factors. Common factors of 6, 8, and 12. Find T intersection N. Here are your options. You have 2, 3. You have 2, 3, 4. You have 3, 4, 6. You have 2. Solution. Let's solve it. Solution. Your first task is to list out cost. This is set builders in describing. Alright? So list out your elements in T. What will it be? Set even numbers from 1 to 12. What will it be? 2, 4, 6, 8, 10. Will I add 12? Yes or no? Yes. Yes. To 12. So add 12. That's 12. Okay? Next up, find N. N is equal to the same common factors of 6, 8, and 12. What's a factor? A factor is simply a number that can divide another number without a remainder. That's all. So which number can divide 2? That same number can divide 8. That same number can divide 12 without a remainder. Which number is that? 2. What else? 4. 3. 4. 5, 6, 7, 8, 9. So just 2, right? Alright, just 2. Alright. Now say find T intersection M. For intersection, we said take the one that what they have in common. What's the answer here? 2. My answer is C. Let's take question 2. Question 2 says if Q equal to factor of 18 and T is equal to prime number between 2 and 18. Find Q intersection T. Okay, we have 2, 3. We have 2, 3, 18. We have 2, 3, 9. You have 2, 3, 6. Let's solve it. Alright, so case 1, list out the elements in Q. List out all elements in Q. For Q, what do I have? Factors of 18. Those numbers that can divide 18 without remainder, what do you have? 2 can divide 18 without remainder, that will give you 9. What again? What again? After 2, what next? 3. 3 can divide 18 without remainder, that gives you what there? 6. What else? 4, no. 5, no. 6, no. 7, no. 8, no. 9. Alright. 9. Okay, what do you mean there? 10, 11, 12. Okay, what's the last thing there? 18 again? 18. So these are the factors of 18. There's 6, right? Yes. Yeah. So 2, 3, 6, yeah, 9, and 18. 18 about 2 gives you 9. 18 about 3 gives you 6, 18 about 6 gives you 3, 18 about 9 gives you 2, 18 about 2 gives you what there? 1. Alright. Let's get T. What's T there? Prime numbers between 2 and 18. Now hang on. Let's analyze this. So 2 to 18. 2 to 18 is 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 17, 18. That's 18 there. They said, listen though, they said between 2 and 18. Please, if I'm considering numbers between 2 and 18, will I include 2 and 18? I'm looking at numbers between 2 and 18. Will I include 2 and 18? No. No. If I'm having 1, 4, 5, 7, what are the numbers between 1 and 7? Is this 1, 5. Don't do that. In other words, after listening out 2 to 18 now, I will take off 2. I will take off 18. Wow. These are the numbers between 2 and 18. That's the first step. Next we say prime number. What's a prime number? What's a prime number? Huh? What's the prime number? Shall I go to secondary school? Like, you come and just step to this place. You went to secondary school. What's the prime number? A prime number is simply a number that can be divided by just what? Itself and 1. That's all. A number that can be divided by what? Just itself and 1. So, what about is 3 a prime number? Yes, of course. A proper definition is this: a number that can be divided by just itself and 1 without a remainder. Yes, that's the proper definition. So 3 is a prime number. I have 3. Is 4 a prime number? No. 4 over 2 gives you what then? 2. It's not a prime number. Is 5 a prime number? Yes. Is 6 a prime number? No. 6 over 2 gives you what then? 3. 7 a prime number? Yes. 7. What about 8? 2 can divide 3. Is 9 a prime number? 3 can divide this, right? I'll give you 3. 10 a prime number? No. 10 over 2 gives you what there? 5. 11 a prime number? Yes. 11. 12 a prime number? No. 12 over 2 gives you what? 6. 13 a prime number? Yes. Put 13. What about 14? Huh? No. 15? No. 15 by 3 gives you what there? 5. 16 No. 17? 17? Yes. Alright. The task has to find Q intersection T. What does Q and T have in common? 3. Huh? Only 3, right? Yeah, so my answer is 3. Alright, so observe. It's not a assumption. That means my option actually wrong. So the answer is what? That's why I said, please, when you're doing jam questions, always check. It's not always correct. I've said this before in class. The jam options are not every time correct. The answer here is what? Alright, you can call it a day.